Good morning, sir. My name is Ensa Vignesh of class ITB 21951A1276. Today I am going to present a concept video on BW subject. So, my topic is about parallel connection of the resistors. So, let's have a look on the contents. Introduction, unit and symbols, type of resistors, connection and of resistors, and derivation of parallel connection. Introduction. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. The ratio of the voltage applied across a resistor's terminal to the intensity of current through the circuit is called a resistance. So basically, the resistance means the, fl- uh, the opposition of flow of electrons. The relation is presented by Ohm's law, that is V is equal to IR. So this is the resistor, and these are the color codes. Next one is units and symbols of the resistor. The ohm symbol, it is the SI unit of the electrical resistance, named after the George Sime ohm. An ohm is equal to a volt per ampere. Other derived units are milli ohm, that is 1 milliohm is equal to 10 power minus 3 ohms, and 1 kilo ohm is equal to 10 power 3 ohms, and 1 mega ohm is equal to 10 power 6 ohms. So these are the two resistors. One is fixed resistor and another is variable resistor. So these are the types of resistors that are classified into two. First one is the fixed resistor, and the second one is variable resistor. Fixed resistor. Ca- uh, in the fixed resistor we have four resistors, that is one carbon composite resistor, next one is film resistor, and another one is wire bond resistor and resistance wire. Coming to the variable resistor, we have six resistors, six, that is one rheostat, potentiometer, thermistor, humistor, varistor, and photoresistor. Now let's see each one. Carbon composite resistor, it has low inductance, ideal for high frequency applications, and it is very cheap to make, and it has very high very large tolerances. So this is carbon composite resistor. Next one is film resistor. The resistive value of the resistor is controlled by increasing the desired thickness of the deposited film. Resistance up to 10 milli ohm can be obtained. Have tolerance 1% or less. So this is the film resistor. This is the inside mechanism. And next one is wire bond resistor, made by winding a thin metal alloy wire onto an insulating ceramic former in the form of a spiral helix. It is available in very low ohmic and high uh, precision values from 0.01 to 100 Kelvin, 100 kilo ohms. So this is wire bond resistor. And next one is rheostat. Rheostat is an adjustable resistor used in the applications that require adjustment of current or varying of resistance in an electrical circuit. It is a special type of rheostat is the potentiometer. So this is the rheostat, and this is rheostat symbol. Next one is potentiometer. A potentiometer is a pot, in electronics technology, is a three terminal resistor with a sliding contact that forms an adjustable voltage divider. Potentiometers are commonly used to control electrical devices such as volume controls, joysticks, etc. So this is a potentiometer, and this is the symbol of the potentiometer. And next one is thermistor. A thermistor is a type of resistor whose resistance varies significantly with temperature. Thermistors can be used as current limiting devices for circuit protection as a replacement for fuses. So this is the thermistor and this is the thermistor symbol. And next one is humistor. A humistor is a type of resistor whose resistance varies significantly with humidity. So a humidity sensor measures the humidity level by measuring the change in the resistance of an element. So this is the humistor. Next one is varistor. A varistor or voltage dependent resistor function is to conduct significantly increased current when voltage is excessive. So this is a varistor and this is the high voltage varistor. So we can see that varistor is very small, about 1.5 centimeters. And next one is photoresistor. A photoresistor or light dependent resistor, that is LDR, exhibits photoconductivity. Photoresistors in many consumer items such as street lights, clock radios and alarm devices, etc. So this is a photoresistor and this is the symbol. So now let's see the connections of the resistors. So basically there are two connections. One is in series connection and there is another one is parallel connection. In series connection, the circuit remains constant. The current remains constant. So that is the current I is equal to I1 is equal to I3, I2 is equal to so on up to IN. And but the voltage gets add up. That is V is equal to V1 plus V2 plus V3 and so on up to Vn. So the equivalent resistance is R1 is equal to R1 and R1 plus R2 plus so on up to Rn. So in briefly, in series connection, the equivalent resistance is equal to R1 plus R2 plus R3 and so on up to Rn. And on to the next, parallel connection. In parallel connection, the voltage remains constant. That is V is equal to V1 is equal to V2 is equal to and so on up to Vn. So the current gets add up. That is I is equal to I1 plus I2 plus so on up to In. So the equivalent resistance of the parallel connection is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus so on up to 1 by Rn. Now let's see the derivation of the parallel connection. In parallel connection of the resistors, there is a same potential difference at the ends of the resistor. Hence, the voltage in the circuit is equal to uh, so basically अरे 8 minute